Hello. In this session, we're going to describe the applications of electrolysis. As we began the session, we say that electrolysis is the breakdown of an electrolyte by an electric current. And we were able to look at two different types of electrolytic processes, namely the electrolytic cell, in which electric current is used to cause or induce chemical reactions. We also looked at the electrochemical cell, in which chemical reactions are used to induce electric charge. So at this point, we are reviewing by describing the common applications of electrolysis. Welcome. The first application of electrolysis is the extraction of pure elements, and this could be done in different ways. Once in the Downs cell electrolysis, we could extract pure sodium and pure chlorine. In the mercury cathode cell, we extract pure sodium hydroxide, pure hydrogen gas, and pure chlorine. And if the need arises, we could also obtain pure mercury. The purification of elements is a process by which we could apply in the extraction of metals. For example, in the use of lead oxide, reduced by carbon, the process gives us lead and CO2. So we could use electrolysis as a means of purifying elements like metals from their ores. Whenever you have an impure agent and you want to use electrolytic process in its purification, you place the impure agent at the anode and attach a pure agent at the cathode of the same form. Use an electrolyte that has the ions of that element, for example. Should this be aluminium, then we could have aluminium chloride as electrolyte. And the impure aluminium will dissolve in solution to give us aluminium ions, which will So that is similar to what we call the cathodic sacrification of a species in order to protect the central element. So number 4 application after extraction of pure elements, purification of elements, and electroplating, which prevents rusting and corrosion, we have the manufacture of cells. We learned earlier that there are two main forms of cells: primary, mainly the dry cell clench, and to the secondary cell, mainly the lead acid accumulator. So as we learned, again, we can say that the dry cell electrolyte is a non-rechargeable cell. Non-rechargeable in the sense that once the redox process occurs, the solution agents are depleted in the dry cell and they are non-reversible. So the cell is non-rechargeable. The lead acid accumulator, on the other hand, is a secondary cell, and secondary cells are rechargeable. We saw that in the secondary cell we had concentrated sulfuric acid as the electrolyte, we had lead 4 oxide as the anode, and we had lead as the cathode. What happened is that the reaction began at the cathode, in which the lead was oxidized, forming lead ions. The lead ions transmitted the electrons to the cathode, to the anode, and at the anode the lead 4 was reduced to lead 2. Then the reaction between lead 2 and sulfate ions formed the insoluble lead sulfate. At that point, we say that the lead sulfate is reversible, but when you add water to it, effectively it is reversed into the original reagents, namely the anode, lead sulfate, the cathode, lead, and the electrolyte dilute sulfuric acid. Remember, we say that after the recharge, the electrolyte is diluted, and being dilute, it is less effective as compared to the concentrated species. So these are the main applications of electrolysis, and in a nutshell, the importance of studying electrochemistry. So we have said that there is extraction of pure elements through down cell electrolysis or mercury cathode cell, purification of elements at the cathode, electroplating, covering to prevent rusting and corrosion, manufacture of cells, which are batteries that we use in our phones and other gadgets. Secondary cells are for motor activity with vehicles. Thank you.